Hey, this is Warner. We're going to take a look at the constant velocity model problem exercises number 1 through 4. For reference, we're going to use the front door of Westfield Middle School. So here's Westfield Middle School, here's the front door, and we're going to say that it is at 0 meters. Then Ion gets on a scooter and his mom drops him off at 20 meters from that door. So this is where we're going to start. So this is our initial. And then he travels all the way over to Westfield High School. So here's Westfield Middle School. And then he travels all the way over to Westfield High School. So here's the high school, WHS. And this position is 825 meters, and this would be equal to XF. We know that it takes 240 seconds to do that, and we're looking for what is his average velocity. So this is our change in time. We know our equation is XF is equal to the velocity times the change in time plus XI. So XF here is 825 meters. That's equal to our velocity, which is what we're looking for, times the change in time, which here I'm going to take that back out. So our change in time here goes away because it's really not change in time. We know our change in time is 240 seconds. And then we're going to add to that 20 meters. Both sides, go ahead and subtract 20. That's the first thing we need to do. So we get 805 meters is equal to the average velocity times 240. And now when you divide the two, you find out that that average velocity was equal to 3.35. So make sure we make our point really big here. 3.35 meters per second. And that is our first problem, number 1. Let's go ahead and take a look at number 2. In that same problem, so in number 1, Ion is told he can't cut through the grass by the school resource officers. So he actually has to travel on the road. So here we go again. Here is the middle school, WMS. It is at 0. And he travels on the pavement this time. So he starts at the middle school, travels on the pavement, has to kind of cut through and go through here, and finally ends up at the high school. And now he is at WHS, and this entire path was 930 meters. So that's where he ends up. Trip time is still 240 seconds, so he should be traveling faster this time because he's had to go a further distance. Let's go ahead and use our equation, which is speed average. So remember, this is not velocity. There's no direction with it. We're just looking at the overall path length. And we're going to divide that by the total time. Our path length here is 930 meters, and we know our time is 240 seconds. So you should end up with a average speed of 3.88 meters per second, and that's number 2. For number 3, Jamaica drives her car to a friend's house. She has to park negative 20 meters from her house. So let's just say that this is Jamaica's house. So we'll put a big J on it. And her car is over here. And there we go. There's her car. And this is at a position where this is 0. So this has got to be negative 20 meters. Over on the other side is her friend's house. So Jamaica's friend's house. And it's over here. And they're going to drive from here all the way over, and so the car will end up at this spot. She travels for a time, or the change in time here is 800 seconds, and she's traveling at 20 meters per second, so that is her velocity, is 20 meters per second. So the thing that we must be looking for, we already know the initial position, but we do not know the final position, so we've got to find it. So final position is equal to velocity times the change in time plus xi. This is equal to 20 times 800, and then we're going to add to that negative 20. So we're really just subtracting 20 to find that final position. So 8 times 2 is 16, so that'd be 16,000 minus 20 and we know we're dealing with change in position here, or just the final position, and that final position is going to be 1,580 meters. Last one we're going to look at before I have you go to another video is this one, and it says, while building the tunnel underneath the French Channel, deja vu, the drill operator moves at a pace of 1.23 meters per second for 3,623 seconds. They want to know what is the displacement. So let's review. We know path length is equal to distance, and we know that displacement is the change in the position, and that's equal to the final position minus the initial position. They want us to find that displacement. So the equation that we've talked about in class for this one is velocity is equal to the change in position over the change in time. So we can use that one, or we can use our standard equation we've been using. XF is equal to the velocity times the change in time plus the initial position. You'll notice that if I move the initial position to the other side, that is XF minus XI, which is the change in position. So this is XF minus XI is equal to the velocity times the change in time. And we can do the same thing with this equation. I can go ahead and just put the change in time, multiply it by both sides, and I end up with velocity times the change in time is equal to the change in position. So either equation, they actually are exactly the same. So if we would work this one out, we would say velocity times the change in time is equal to the final minus the initial position. And that is displacement. So let's go ahead and just use this equation, and we'll simplify it and say, well, this is really just the change in position is equal to, now our velocity is 1.23 meters per second, and the time is 3,623 seconds. If you multiply the two together, you should end up for number 4 with the number 4456.29. And we probably need to go ahead and put that into just 4 numbers here, since we've got 4 here and 3 here. So it would make sense to do 4 numbers. So 4456, and then that would be in meters. And that would be the displacement of the drill. We also need to have a direction here, and so because we've got 4456, if we put a positive in front of it, that would give it a direction. And that is the end of the first constant velocity motion problem exercise solution set.